Dear student, welcome to the lecture series of thin film technology. Dear student, in this lecture series we will discuss about one of the most important one of the most important deposition technique used in thin film technology, which is known as pulse laser deposition. Dear student, please note that pulse laser deposition is a kind of physical vapor deposition process. And this the topic is basically the pulse laser deposition is a very important topic in thin film industry. So this lecture series will be split into five different parts. So in these five different parts, we will discuss about the processing steps involved in pulse laser deposition process, advantages and disadvantages of pulse laser deposition processes, and what are the key parameters associated with the pulse laser deposition process. Since, dear student, as I have discussed in previously that the pulse laser deposition is a type of physical vapor deposition process, then dear student, what do you think? What is the pulse laser deposition process? Or what is the pulse laser deposition technique? Pulse laser deposition technique is a type of physical vapor deposition process. So in this pulse laser deposition, we deposit thin film by physically, but not by a chemical reaction. So pulse laser deposition is a kind of physical vapor deposition process in which high power pulse laser beam is focused inside a vacuum chamber, and that focused beam strike and vaporize the target or source or precursor material. So this vaporized or target source or precursor material basically is transported and deposited as a thin film on a substrate inside the pulse laser deposition chamber. So let's explain this in a simple word. Pulse laser deposition is a physical vapor deposition technique. What do you think? What is a physical vapor deposition technique? Dear student, physical vapor deposition technique is a technique in which no chemical reaction involved. So in this physical vapor deposition technique, there is no chemical reaction involved. So the precursor material in physical vapor deposition technique is either evaporated, ablated, or and then it is transported without any chemical reaction inside the chamber onto the substrate, and then it is deposited as a thin film. So dear student, PLD is a kind of this kind of method. So it is a kind of physical vapor deposition technique which don't involve any chemical reaction. So but the difference in the pulse laser deposition with respect to the other physical vapor deposition technique is that pulse laser deposition used high power pulse laser. So basically high power pulse laser beam is in pulse laser deposition chamber is targeted onto the surface of the substrate, onto the surface of the target or source or precursor material. Okay, so the laser of high energy is basically focused and it is targeted onto the surface of the precursor or source or target material. Okay, and due to the high energy of the laser which is focused onto the surface of target or precursor or source material, is this material basically get evaporated and form a plume of plasma. Okay, and that plume of plasma is basically transported onto the surface of the substrate which is present inside the chamber of pulse laser deposition setup. Okay, so that is transported onto the surface of substrate, and after transportation of the plume or the precursor material onto the surface of substrate, it just basically condenses and it is transferred into a thin film. So in a simple word, in pulse laser deposition technique, a high energy powered beam is basically focused onto a source or target or precursor material, and due to this high energy beam, the source or target or precursor material basically are evaporated, and they are then transported onto the surface of substrate, and then they are converted there into highly crystalline oriented thin films. So dear student, what do you think? What laser do when it is interacted uh, to the surface of the precursor or source or target material in pulse laser deposition setup? So when the laser of high energy fall onto the surface of the target material, the laser pulse is absorbed by the target material. So laser with high energy get absorbed by the target material. So the energy of the target material become too high, which is converted into electronic excitation. So then we, like, due to electronic excitation, we get a higher number of electrons, okay? And due to the higher number of electron, there is usually occur thermal, chemical and mechanical energies in the target material, okay, and due to which they will result in evaporation, ablation and plasma formation and even exfoliation from the substrate material. Okay, so when high energy of laser beam fall on target material, they basically, that the energy of the beam is basically transferred into electronic excitations. So there will be a large amount of free electron with very high energy. So that energy excitation basically is converted into thermal, chemical and mechanical energy. And when this excitation energy of electron is basically transferred into thermal, chemical and mechanical energy, this will cause an evaporation, ablation or plasma formation or and even exfoliation of the source material. So due to this, the source material will get evaporated and ablated and transported onto the surface of the substrate from the precursor material. So let's make it quite simple. So in laser ablation, initially high energy laser basically fall on the surface of the target material, and it will penetrate inside the target material, but it will depend on the energy of the incident laser and also the refractive index of the target material. So when this high energy laser basically fall onto a target material, the energy of the laser is converted into electronic energy of the source material. So basically is this basically the incident high energy laser knock out the electrons or basically excite the electron of the source material, and when the electrons are excited inside the source material, they basically result into a very high energy which is converted into thermal, chemical and mechanical energy, and due to these energies they will cause the evaporation, ablation and plasma formation of the source material, and in this way the source material will be transported onto the surface of the substrate for deposition. Dear student, what do you think what the term ablation mean? Let us make it, or let us explain it in a simple word. So dear student, the pulse laser ablation is basically, in pulse laser ablation, a laser penetrate into the surface of the sample. The penetration of the laser will depend on the wavelength and refractive index of the target material. So when the laser is penetrated, it will generate high energy electric field, which will be enough to remove the electron from the bulk sample. The generated free electron collides with the atom of the bulk sample. Okay, so they will transfer the energy into the heating of the surface, which will result into evaporation. So basically the term pulse laser ablation mean that the incident laser with high energy basically will penetrate into the sample surface. Okay, and when the laser of high energy penetrated into a sample surface, this will result into electronic excitation. So there will be enough electric field inside the sample and even at the surface of the sample. So this resulting electric field will basically cause the free electrons, and these free electrons will continuously collide with the atom of the bulk sample, which will result into evaporation of the source material. So let's make this method explain this method in a simple word. Dear student, please note that in pulse laser ablation, a high energy laser in the form of pulse will fall onto the surface of the sample or precursor or source material. Okay, so when the laser of high energy fall onto precursor or source or sample material, it will basically cause an excitation energy. Okay, so the electronic energy or the electric field inside the precursor or source or target material will increase. There will be lot of free electron due to the incidence of high energy laser. Basically, the high energy laser knock out many electrons from the sample, and these electrons have very high energy. So these high energy electrons will basically collide inside the source target or target material, and when these high energy electrons collide with the source material inside the source material, they will result into evaporation of the source material. So in this way, with the laser ablation mechanism in pulse laser deposition, the source material is evaporated. We can explain laser ablation by a simple animation like this. So this is basically a high energy laser material. So our explanation is about the material, which is aluminium lead titanate. Okay, so we basically this was the material source material on which the high energy laser is basically incidented. Okay, and this energy laser basically the energy result into excitation of the electron present into the source surface, and then they are evaporated. So due to this, you can see flashes of light in the sample. So dear student, in a nutshell, the the pulse laser deposition is defined as it is a type of physical vapor deposition process in which high-powered pulse laser beam is focused inside a vacuum chamber uh, of strike and evaporate the target or source material, and then it is deposited as a thin film onto a substrate. So make this definition quite simple. The pulse laser deposition is a process in which a laser of high energy is incidented in the form of a pulse onto the surface of the target, source or precursor material in vacuum, and when this high energy laser fall onto the target, source or precursor material, this due to high energy transfer, it will result into evaporation of the precursor, source or target material, which will be then which will be then transported onto the surface of substrate and which will be then deposited and which will be then transported and then deposited on the surface of the substrate, result into a thin film. So dear student, this is a part 1 of our lecture series of pulse laser deposition. So please follow our next parts for briefly explanation of the mechanism involved in pulse laser deposition technique, and also the merits and demerits of pulse laser deposition techniques. So thank you for watching this first lecture series of pulse laser deposition process.